This video lesson deals with the division point of a line. So I'll remind you, in our last video lesson we learned about the midpoint of a line, and remember the midpoint divides a line in half. So the midpoint is found halfway along a line. Now we're going to be looking at points that divide a line in fractions other than a half. So the position of any point on a segment can be found using a fraction or a ratio. Well, we've already experienced that with midpoint. The fraction was 1/2. So before we continue any further on division point, we're going to review a little bit what is the difference between a ratio and a fraction. So if you look here, you'll see that we have our line segment AB, and we have point P that divides the line AB. So we're going to complete these statements below about this line. Point P is situated how far along segment AB? So if we look here, we'll see that there's indications. So our segment is AB. That means we go from A to B. So from A to B, point P is here. A to P is 3 units along the line. So this section here is 3 parts of the line. This section here then has 2 parts, as we can see, because here we have 4 and then 5. So what is the fraction that point P divides this line into? Well, it has 3 parts out of a whole. How many parts do we have altogether? Well, we have 3 parts out of the whole, which is 3 plus 2 parts, so that's 5. So the fraction that P divides the line in is 3 parts out of a total of 5 parts. So point P is situated 3/5 along segment AB. Now we can also say that point P divides the line into a ratio. A ratio is a comparison of parts. So the fraction does the part divided by the whole, while the ratio is going to be a part and a part. So it divides the line into 3 parts to 2 parts. That would be our ratio, 3 to 2. Now the next statement, point P is situated what fraction along segment BA? So now the difference is, instead of starting at A like we did in the first point, now we're starting from B. So from B to A. What is the fraction that P divides the line into? Well, now since we're starting from P, this is the part, and this is still the whole. So point P is situated 2 out of 5 along segment BA. So it's situated 2/5 along segment BA. And then the last statement, point P divides segment BA into what ratio? Well, again, we're starting from here. So when we're talking about ratio, we're talking about the parts. Well, there's 2 parts to 3 parts. So the ratio now is 2 to 3. Point P hasn't changed positions, but it's important to note that we need to understand which point we're starting with. Are we starting with the endpoint A and going towards B? Or are we starting towards B and going towards A? So it's also very important to note the difference between a ratio and a fraction. So when we have a ratio, we're always comparing part to part. So an example here would be 1/2, 1 part to 2 parts. Well, that could be expressed as a fraction also. If we put it as a fraction, it's part to whole. So the first part is 1, so that's the number on top. The whole is the 1 plus 2, because we have 1 part and 2 parts. So altogether that gives us 3 parts. So our fraction would be 1/3. And as I already stated, it's very important to know the difference between going from A to B and B to A. We always start from the letter that's written first. So in this case we start at A, in this case we start at B. Now to find the coordinates of that point P that's dividing our line, we use this formula here. So this is how we find the coordinate of x of that point, and this is how we find the y coordinate of that point. So we take x1 is expressed here. You can look at this diagram below to help you. So x1 is the x-coordinate of the end point I'm starting from. So in this case, we're working with line segment AB. I'm going from A to B. So my A is my x1 and y1. B is my x2, y2. So my formula is x1 plus A over B. This is the fraction that point P divides the line. It's also expressed here. And then this part here is basically your change in x, x2 minus x1. Same thing for the y, y1 plus our fraction that P divides the line in times our change in y, or y2 minus y1. And like we did with the midpoint equation, we can break this up and do it separately. Find the coordinate x, find the coordinate y, and then put them back together in brackets like this with our comma to show the coordinates. So if we examine this diagram a little bit closer, our fraction AB, that means that this here is the portion A and B is the whole. So P divides the line using the fraction A over B. B is the whole, A is the part from the point we're starting from. Let's try all of this in an example. So point P divides the line segment AB in a ratio of 3 to 1. Important to note here, AB, meaning we'll be starting at A. Its endpoints are A 3, 7 and B negative 4, 10, and you'll see that we graphed them already here for us. The coordinates of point P can be found using the following calculation, so we're going to determine the coordinates of point P. So the first thing we need to know, well, we have a ratio. We're given that P divides the line in a ratio of 3 to 1. That means that from A, because again, we're told segment A to B, so that means A to B in this direction. P divides the line in a ratio of 3 to 1. That means that this, from P to A, that's 3 parts, and from P to B, that's 1 part. So we need to put that in a fraction to put it in our formula. Well, 3 to 1 corresponds to the fraction 3 over 4, because remember, 3 is the part and 4 is the whole. So it's 3 parts out of 4 parts altogether. Now, to determine the coordinate, we'll be using the formula we saw earlier. The first thing we need to do is we need to identify our x1, y1. Well, we are told in the problem we're going from segment AB, so A to B. That means A will be my x1, y1, and B will be my x2, y2. So I can go ahead and use my formula. I'll write it down. I'm going to do them separately. I'll do x first and then y. So the x coordinate, x1 plus my fraction times the change in x, which is x2 minus x1. So my x1 is 3, plus my fraction is 3 over 4, and my x2 is negative 4 minus my x1, which is 3. You have to use your order of operations here, so the next thing you're going to do is simplify the bracket. So negative 4 minus 3, that gives us negative 7. And then we're doing 3/4 times negative 7. On your calculator, you can do 3 times negative 7 and divide by 4. That should give you negative 5.25. And then we do this addition. 3 plus negative 5.25 is going to give us negative 2.25. That's my x-coordinate. Now we'll do the y-coordinate. So my yp equals y1 plus a over b, bracket y2 minus y1. So my y1 is 7 plus 3 over 4 times the change in y. So y2 is negative 10 minus 7. I'm going to ask you to pause the video here and try to do this calculation on your own, just to make sure that you're able to do the order of operations correctly. Pause the video, please. So you see here we have the complete solution. We simplified the bracket, we multiplied negative 17 by 3 over 4 to get this, and you should be finished with negative 5.75 for your y coordinate. So the last step is to write what the coordinate of P is. So P is negative 2.25, negative 5.75. Let's take a look at this last example. I'm going to start it for you, and I'm going to ask you to finish it on your own. So I'm going to read the problem and label my diagram at the same time. So I'm given endpoint A, which is negative 3, 4. So I'm going to label my A, negative 3, 4, and B, which is 6, 1, of segment AB. Point P divides segment BA in a ratio of 1 to 2. So be careful here. Segment BA in a ratio of 1 to 2. So BA means we start at B. B to A in a ratio of 1 to 2. So it's already labeled here for you. The first part from B to P is 1, and then from P to A is 2 parts. Now we have our ratio of 1 to 2, but we need to put that in a fraction. Well, as a fraction, remember it's part over whole. We start with the first part, which is 1, over the whole. Well, 1, and the whole is 1 plus 2. Oops, plus 2. Which just gives us 1 over 3. That's the fraction we'll be using in our calculations. Now, the next thing you need to identify is what is x1 and what is y1. Well, since we're told the ratio in terms of B to A, that's the way we're going to be working, from B to A. So that means my B is x1, y1, and my A is x2, y2. So now I'd like you to finish the problem using the formulas that you've learned in this video, and please bring your work to our next class.